Welcome back. In the previous lesson, we have discussed about what is data science, data analysis lifecycle, and different types of machine learning algorithms. Now, what are the knowledge that we actually have? And I'm going to demonstrate and try to explain you the stages that generally we will do for doing any kind of a machine learning model. And for this case, I'm going to take an interesting topic called face recognition. And my idea here in the face recognition is I'm going to build a simple face recognition that will detect male or female. The main aim of this lesson is to give you the essence of data science and help you to understand what are the process or what are the steps that was there, so that whenever you're trying to build a model or any kind of analysis, you can understand, okay, what are the steps that we need to perform. But however, in order to understand the in-depth concept of the face recognition, I highly recommendable to go to our course, where the course is currently available in Udemy, and you can find the URL in the description. And there are already 24,000 students are already there and also learning it. And this course actually, it's 11 hours nearly, or 10.5 hours. So complete information is there and how exactly we're going to build the face recognition. And in this course, I also explained the concepts on the OpenCV and how to build the machine learning model and how to develop a web app in Flask and deploy in the cloud platform. So which is the end-to-end flow is completely explained in this course. And you can find the links in the description. Okay, so without further ado, let's get into the topic of the face recognition. My first question to you is how a computer sees a person. How a computer can identify, hey, this is the person X, hey, this is the person Y, and he's a male, she is a female, he's happy, she's sad, or something like this. How a computer can able to understand and identify it. And probably few of the students who are actually watching this video, they think like the computer is actually sees the image in terms of ones and zeros. And you are right. But now the point is that we have a data. So this is the data that whatever we are having, and how we can put the knowledge or the data into the computer so that we can give the computer ability to think. It's very difficult, right? So data science will help you to do this. So first of all, let's try to understand from the human standpoint of view is how a human identify a face. How a human identify he's a Ram, she is Sita. How a human can identify it. Let me give a hint. Let me show you one image. Can you guess this person? I can give you a 5 seconds time. 95% of people have already identified this person. And he is none other than Cristiano Ronaldo. The same picture. And this is the picture. And which actually also tells the same information. And let me give you a few glimpses. And he is the Cristiano Ronaldo. And this is the edge of the Cristiano Ronaldo. But still we can able to identify this picture contains a Cristiano Ronaldo, right? And that's how our human brain will also work. Human brain will not look into each and every minute detail, like what color and some styling and etc. It will only look into some kind of pattern. The one of the pattern it actually look is the edges, outlines. Okay, this is what the outlines of the person, and that's also one of the feature which actually goes to our brain, and our brain will actually identify this is the person Cristiano Ronaldo. Cool. Now this is the data and this is what the knowledge that we have acquired. Now how the knowledge that whatever we know and how whatever the information we try to understand, how we give this knowledge to the computer. Before moving into complete training and all the details, what I'll do is let me explain you a little bit of image processing and what is the image data. Generally, you can say the image is actually the combination of vectors or values. Image can be described as a vector graphics or raster graphics. An image is actually stored in the bitmap. What do you mean by a vector? What exactly I mean by the image is actually has been created based upon the vectors and values. I'm just telling you from the computer standpoint, the image is just a vector or values. It's simple values, some numbers. So let me give you an example for this. For that, what I'll do is let me open a Python editor. So here I'm using the Jupyter Lab, and let me try to read one image. Let's say the image I want to read is this, which is a Cristiano Ronaldo. Okay, probably let me take the small image 2. Okay, this is the simple image, and the name of the image is image_2.jpg. I want to read this image. And for that I use few libraries. Now in order to read the image, something like img is equal to mread. Now just let me read the image, and here it is image2.jpg, and I have successfully read the image. Let me print the image and show you what exactly the computer is seeing. And here it is. And what you can see is some numbers. Some 87, 205, 185, 88, 210, 186, or something like this. It's a big array. It's a very big array. Some numbers. And if you look into the shape of it, and it says that we are having 343 rows, 473 columns, and depth is 3, which means the height of the image is 343, and 473 is the width of the image, which is the 473 pixels, and depth is 3. Basically this 3 represents RGB, red, green, and blue. Okay, I don't want to confuse you, so I just want to show you, just try to understand what is the image. It actually contains some numbers, but each and every number has a meaning. Okay, now I told you there is a depth is 3 is there. Generally any color image if you take, there actually contains a 3 channels: red channel, green channel, and blue channel. What I mean is, if I take the image, the same image which I have shown here, and for this image there are 3 layers are there: red layer, green layer, and blue layer. It's actually common for all the images. And if you split it and actually see in very detail, red layer or red region will actually contains the information about the red, and whereas green contains the information on green colors, and blue is actually contains the information on blue colors. And here what you can see here is a red region, blue region, green region in the here, where in the red region there you can see some white color is actually getting shown, which means that this particular region is actually contains a red color. Whereas the green, you can see basically the background is majorly highlighted, or most of the white color is there. And whereas in blue, you can see the wings is actually having the white color, and rest all actually it's a little bit dark, which means that's a blue region, or the blue color or blue information is actually present over there. Overall, if you see, this is a parrot, right? Overall, what I can say, the information point of view, the overall red region, green region, or blue region, overall it contains a parrot, right? So generally any kind of image processing or an array processing we will generally do for an image, it is highly recommendable to work on a grayscale image like black and white, because the information point of view, both color and black and white actually contains the same information. Here in the color image, there are 343 rows, 473, and the 3 layers. So which, if you see, the number of values that the computer need to process is very high. And whereas in the black and white, even though it's still very high, 343 into 473, but the computational point of view, in the grayscale, it was reduced to 3 times. So that's the reason it is always important to do image processing concepts, or whenever you're trying to build a model, in the grayscale. But however, there are also some use cases are there. Depends upon your use case. It is sometimes you need to work on the color images also. But from the face recognition point of view, it doesn't matter whether the image is a black and white or color. We can still detect the person whether he's in black and white or in the color. So let's try to deep dive into the image and little bit understand more on what exactly happening. Let's consider this is an image and which contains the number 2, and that's what we know. But the matrix point of view, since it's a color image, there are 1200 rows, 1200 columns, and depth is 3. And as you already know, it doesn't matter that whether you are using the color image or grayscale image, the 2 is still 2. Information is still the same. So that's the reason generally we will work on only on the grayscale. So here I remove the 3, so it's a grayscale image. Now let me take one thing. If I take this particular portion and zoom it, and what you can see is something like this. That's what generally you will notice. When you zoom an image, zooming and zooming to till the last end, there are some boxes that you already see. Some boxes, some color, basically so color, some boxes is what you're going to see here. These boxes are called pixels. Okay. Now the pixels actually are numbers, and the range of pixels is between 0 to 2 to the power of n minus 1. Any image you take, it is a 8-bit image. So for a 8-bit image, the range of pixels is between 0 to 2 to the power of 8 is 256, minus 1 is 255. So the 0 color represents the dark color, means black, and whereas the 255 number represents the light color. If you render it 255, it is a white color. If you render the 0, it is a black color. So hence now what you can see is that if you take this image and if you take the small portion of this, the basically what you see is some dark yellow, gray, and grayish color and all, right? So internally these are numbers. So 0, which is a black color, 230 it's a white color, 255 it's a white color, 53 it's again a gray color. So it's actually the intensity of colors between is black to white. That's what exactly you're seeing here. So the numbers that whatever you're seeing, the previously that I show for an image, is actually contains a meaning. It actually contains the information whether it is a black color or light color or darker color. It is also same true for the color images. But let's put our focus only on the grayscale image. So by now, hope you understand that what is an image and what are the values that was there in image and how the image is generally being constructed. Now let's put the data science here. What is data science that we have explained in the previous lesson? Data science is a concept or a skill of extracting the information or a knowledge from the data, and which is called data science. In order to do this, there are 3 types of process. Obviously, data transformation or data preparation, analysis, and modeling. That's what we have discussed in the previous lesson. Now let's talk about the preparation. What kind of preparation that we can do on top of this? As I told you, we have to arrange and organize the data and summarize it is what we have to do in the data preparation. And here also we will do the little bit of same, but it's a quite different when it comes to the regular data. And here what we'll do is the data transformation. Generally the images what we call is a unstructured data. The meaning of the unstructured data is generally if you see every image has a different pixel range, different width and different height. So general process is that we want to bring all the information into some fixed range. Okay, so which is called image resize. So in this case, the image that whatever I'm having, which is in the 1200 by 1200, I bring that image into 10 by 10 pixel. But still the information is still same for me. It still actually captures the information, which is 2, right? Now what we'll do is we're going to reshape it. Reshape in such a way the computer can understand this. So what I'll do here in this case is I'll convert this image into either row matrix or column matrix. Something like this. So what I did is So what I did here is I took this image, reshape it, and I'll take the each and every row and then I put everything in a side by side, and which is what it looks like this. And what you can notice here, basically I converted into either a row matrix or a column matrix. The information that you can correlate here is it's a barcode, right? Exactly, that's what how the barcodes are created. But however, the concept of barcode is a little bit different. I don't want to bring into that concept, but internally what you see here is some kind of a barcode information, and basically internally these are some numbers. Okay, so now once you have this information as a part of analysis, probably we can see is we can count the different parts, like how many black bars are there, what is the width of each bar, what is the position of bars, position or index of bars. So if you have this information, and then we can easily identify this number, and probably this pattern will be different for the different numbers. Obviously that's the case, right? Exactly. So that's one of the way we can identify or build the model for number classification. And now what we can do is we can train these images, and we can bring some rules and saying like, if I found this pattern, and I can say this is a number 2, number 3, or so on. Okay, now bring our focus to a face. How we can do it for a face, because face is not a barcode. We can't bring that information into a barcode format. There should be some kind of a way in defining it. As I told you in advance that generally we have to look into the pattern, means some edges or lines or something like this we have to look. That's what exactly we will do here. Obviously the type of steps that generally we'll do is converting into grayscale. Resizing, generally it's required in order to bring all the images into same shape. It is required. Reshaping, transforming, and building model. So what we'll do is that let's take an image of MS Dhoni, and we don't want the color information, we just want the black and white. That's what enough for me. And then obviously we know that each and every color is actually the pixel. Now the recognition algorithm generally we will follow is something like this. We'll take an input image, detect the face, identify the shape or transforming. Basically here we're looking to the base identification of shape, like what is the jaw position, what is the ideal position of the eyes, nose, mouth, eyebrows, and etc. So this is actually a key elements to identify any person. And basically we can use this deep learning network to identify this. There are already some bunch of models which is already there, and which will actually extract the information for us. And after that, we can use the algorithms like classification, similarity detection, and the clustering technique, with the help of which we can actually identify the person. Okay, so let's try to understand what exactly I'm trying to say. So here, as I said, let me take the image and we'll detect the face. And once we identify the transformation, the output of the deep learning model will be some kind of a numbers. And here the range is from 1 to 128 embeddings. So that is called the phase embeddings or phase vectors. Now we'll take this phase vectors, and our idea is, now we'll take this phase vectors and we will build the model. Okay, so now for the sake of simplicity, what I'll do is let me build the male or female classification model. So here the algorithm what I'll use is the very simplest algorithm, which is k nearest neighbor algorithm. So for that, what I'll do is that let me take the list of images. Some males and females are already there with me. I'll take these images, and some in the male folder I have all the male images, in the female folder I have all the female images. And now what I'll do is that for each and every image, let me calculate the embeddings. Means for this image I'll get this embeddings, and for this another image I'll get another embeddings, and so on. And I'll put this information in a matrix. So basically the length of the array is 1 by 128. So here let's say I'm having the 100 images, let's say 50 male and 50 female. Then I'll put all the information into something like this, like 100 by 128, where 50 rows contains the male and 50 rows contains the female information. And then we also have the y is there. Assume that 1 is male and 0 is female, and just try to classify it. So in this way I'll prepare the data. Okay, for the sake of simplicity, in order to understand our algorithm, let me take the two columns, x1 and x2. And let me take this x1 and x2. Let's say this is my x1 and this is my x2. Okay, so let me take, this is my x1 and this is my x2. Okay, if I project this x1 and x2, what happens is probably I can say, like, there are 50 samples are there, and I know that this group is male and this group is female, something like this, a scatter plot which I will x1 x2, and the data points in x1 x2 if I carefully place in the scatter plot, and it looks something like this. And here I have color it. So for male it's a red color, and for female this is a green color, and this is what the range that was there for the female, and this is the range I found for the male in a 2 dimension. Now let's say we have some unknown data point came. Now tell me whether this unknown data point is male or female. How you will identify it? And that's what the k nearest neighbor will actually help you. So for the sake of simplicity, in order to understand what is k nearest neighbor, let me take the 2 points, point A, let's say this is my point A and this is my point B, and I want to identify the distance between point A and point B. In order to identify the distance between point A and point B, what we can do is that we can easily calculate the equivalent distance. Equivalent distance will say that, let's say this is my x and this is my y, and my data point is x1 and y1. Probably this is my x1, and this will be, if I project it, this will be my x2, and this will be my y1. Probably this will be my y2. Okay, so now the distance, this is my modulus of x2 minus x1, which is my distance, and similarly the distance here is y2 minus y1. Now what we want to do is that we know this distance, we know this distance, which is probably from this to this and this to this. Now this look exactly like a right angle triangle, and from the Pythagoras theorem let's say this is my point C, and we know that from Pythagoras theorem, which is my AB square equal to AC square plus BC square. And this is what the distance of interest that I'm having. So I can say the AB square is my D square, which is equal to AC square is x2 minus x1 whole square, and BC square is y2 minus y1 whole square, and hence D equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square. That's the distance, which is what my equivalent distance here. Now, using this concept of equivalent distance, what I'll do is let me calculate the distance from each and every point. This point to this point, this point to this point, each and every point that was available. And similarly, we'll calculate distance from this point to female points also. Every point. Okay. So now we found the distance from each and every point, and we know the distances also. Now here the k is coming to the picture. Let's say assume that the k equal to 5. So which means that 5 nearest points is what I want to consider. So out of all these points, I need to select 5 points which are actually closest to my unknown point. If I do this, probably I can say these are the 5 points which are actually closest to my unknown point. Now tell me, what is the probability of male? Out of 5 points, I identified 3 points, which is 0.6, 60%. And now what is the probability of female? Out of 5 points, how many are there? Which is 2. That is 0.4, 40% probability. Now from here, what I can say is that since the 60% probability is more than 40% probability, I can say that from the probability standpoint, this is the more closer to the male, I can say that this unknown point is a male. So likewise, our algorithm, whenever we have the data is already there and we have already organized in the proper format. Now if unknown point is there, now in order to predict the unknown point, we can simply use the KNN algorithm. Based upon the distance, we can easily find out which data point it belongs to. So obviously there are the different algorithms are also there, and each and every algorithm has their own advantages and limitations also there. And this is one of the simplest method which we can use for the face recognition. Cool. So that's how the face recognition will work. And here the recognition algorithm is, I can use the input image, detect the face, transform it, and then build basically find out all the data points or some kind of you can say the key points, and from the key which I can able to get from the deep learning model, and from there we can get the embeddings, and using the machine learning algorithm like KNN, and I can easily find out what is the probability of male and probability of female, and using which I can give this is the male and this is female. Cool. So this is how a recognition algorithm will work. Let me demonstrate a code how this process will work.